Okay, coming to you live, on recording. Welcome to Calculus in the PM. I'm your host, Mr. Shindelka. Chain rule has just begun. So we're working on this. We've identified the inside function, we're calling it u, x squared plus 1. Then subbing that in, the outside function is 5u cubed kind of thing. Okay, according to this notation, the derivative of the y expression, dy by dx, is equal to dy by du. Any idea what we do to find dy by du? Yes. The derivative of the y expression with respect to the variable u. Well, that's exactly what we have here. Does that make sense? Just do the derivative using the variable u. And then, this keeps falling down again. Trip. So, I'm going to go with this and say dy by dx. I'm talking about this expression here, right? Is equal to, well, dy by du. What's the dy by du part? The derivative of this expression here. 15u squared, right? I'm going to call this 15 squared. And then multiply that by du by dx. Hey, this is what we're talking about there, right? U is equal to this in terms of x, right? So do the derivative of the u equation with respect to the variable x, right? Which is 2x plus zilch, right? Okay, so 2x. See where we got that? That's why I color-coded it. Okay. That looks easy enough. Except, let's get it all back to the original variable. So we're going to sub backwards. U is equal to x squared plus 1. Also, at the same time, does it make sense to move our number out in front? 2 times the 15, we'll group that. Numbers with numbers, letters with letters, expressions with, okay. So let's move this actually 2x. We're going to move it out in front and multiply it by the 15. Does that, that's not earth-shattering? But this u, we're going to keep in the behind, and we'll sub in x squared plus 1. So this dy by dx equals. So I'm going to drop the colors because they're all mixed up now. 2 times 15 is 30x, and then the u squared becomes x squared plus 1. Okay. Now, once you learn this rule, it's not too bad, because before, without this rule, you would have had to write this out with 3 brackets, right? X squared plus 1, x squared plus 1, x squared plus 1, and apply the product rule 3 times, right? Like for a three-factor system. You can do that, but I don't recommend it. This is way easier, and it's actually pretty simple. Okay? Now, I said this is good to think about because this is a skill we're going to use later on in a later unit. What if we thought of it this other way, though? When I say this other way, we'll do the exact same question, so we should get the same answer. We're going to think of it like this. F of g of x, where f is our outer function, 5 something cubed, and g is our inner function, x squared plus 1. Does that make sense? So, or, and this is the better method for this section, but later on the other method is pretty useful. You need to understand both ways. It's the same method. Actually, do you guys realize what this is? This is the derivative of the outside function, really, right? The outside function being the 5u cubed stuff, right? Times the derivative of the inside function. That's the 2x that came from here. Well, really, that's what this is. If you got this g nestled inside the f function, it says take the derivative of the outside function, take the derivative of the inside function. multiply them, no adding involved, right? So let's just try this out. Thinking this way. So I'll still use blue for the outside function. This says take the derivative of the outside function, f prime of, and then leave the insides alone. Do you guys see that? So we're going to say, what's the derivative of the outside function? I've got to move this because I can see my 3 then. It's, the outside function is 3 times 5, it's 15 something squared. Now I always say stuff like something squared just because it doesn't matter that it's x squared plus 1, you're not touching it. So we're going to do it this way. The derivative, so I'll say y prime is equal to, just because it was originally called y equals, right? 5 something cubed, oh, squared. Sorry, I got to skip right into the derivative here. 5 times 3, so 15 something squared, because, right? And according to this rule, though, keep the inside as is, don't change it. So x squared plus 1. Then multiply that by the derivative of the inner function. In this case, x squared plus 1's derivative is 2x. Hey, it's the same thing as the other, isn't it? Should be. I'm going to move that 2x times the 15 in front. 30x. But like I say, both, it's the same information, but both are worthwhile doing. Yeah. Anything? Well, let's just see. Got lots of empty space there. Let's leave some. Let's try that. Find the derivative of this guy. Now, we're going to use that f of x notation stuff. Okay? Like I have both rules, or the same rule, written in 2 different ways. It's still the derivative of the outer function, derivative of the inner function. Derivative of the outer function, derivative of the inner function, okay? So, in order for us to do this easier though, now I typically, after you do these a while, you don't rewrite these, but I would still suggest that we do. Right now, y equals, what's the outer function, what's the inner function? What do you guys think here? But I'm going to use half instead of square root, right? Okay, 6 something to the half power is the outer function. Inner function is 4x minus 3. Okay, so I'm going to go like this. Everybody agree that's kind of the outside function? And I was using red for the inner function, so I'll continue to do that. You get in touch with your inner function. Now, I haven't done any calculus yet, right? I said, well, try this f of x notation, f of x, g of x stuff. We'll use this kind of way of thinking. So we do the derivative. dy by dx just means doing the derivative. It doesn't mean you have to think of it in this notation, though, like the du's or stuff. You don't have to set aside and say u is this or that. But what's the derivative of the outside function? When I say that, I'm just thinking, what's the derivative of 6 something to the half? 3, and then something to the negative. 3. Now leave this bracket alone, and the rule tells us don't touch the innards, right? So I'm still going to write that to 4x minus 3. Then, apparently I'm supposed to look at now g prime of x, multiply that, the derivative of the inside. So then I say it's 4, and that's it. You know how often on the assignment and on the test that's coming up and on this chapter 4 test too. I'll have questions where it says, only show the first step. You would stop here, right? Because you've shown me the calculus. The rest is just algebra. This isn't very tough algebra. Ah, 4 times 3, that's it. 12. Now I could write it like this, 4x minus 3. But you guys are sharp kids. What does that actually mean? Right. Negative, take the reciprocal, and that's a square root. 12 over the square root of 4x minus 3. Okay. What's in black there is strictly algebra, manipulation. Knowing negatives and positives and fraction exponents. Okay. This question here, down here. You could have this question. No, you wouldn't actually. I was going to say, you could use the quotient rule for this question. Right? Let's do it. Yep. I was going to say you could have this on your assignment, but no, because this is composition. What is like the outside function here? The outside function is this. 1 over something cubed, right? The something cubed stuff, like I was going to flip it up and make it -3, but that's one option. But here's another option. Well, I'll show you both. We're going to use the quotient rule, okay? For this. So f prime of x is equal to 1 is the top thing, so quotient rule goes derivative of the top thing, leave the second thing alone, but write it down, right? What's the derivative of the top thing? 0. So it's going to be 0, and then whatever you write down is still zeroed out, right? So 0 minus. I'm going to just start with the minus part. Does that make sense? Top thing left alone, 1, times the derivative of the bottom expression. Now I'm going to only write down, maybe I'll even write down the 0 just to show you. 0 times x squared minus 4 cubed is still 0, minus top thing left alone, top expression left alone, times the derivative of the bottom. Well, the bottom, I'll use blue for this, is this, well, 3 something, so what's that? So it's, well, you got to, okay. I'm going to rewrite this a little bit. Just only, it's not really rewriting it much, but I want to show you what, this is the outside of that. This is the x squared minus 4 is the inside, right? You guys follow me now? Apply the chain rule inside the quotient rule. So what happens? 3 something squared. Do you guys agree with that? The blue? Okay. So 3, 1 times 3, not that you write down. Something squared. You always leave that inside alone when you do that first one, right? So I'm going to just exactly as is. Don't try to do 2 things at once. Then you do the derivative of the inside. 2x in this case. Apply brackets liberally. And always leave the bottom alone squared, right? Don't undo that bottom either. Like, don't work it out. There's usually no need. So I'm going to just write it in black. X squared minus 4 cubed and then squared. Square on a cube is 6. Okay, can you simplify that numerator? Oh yeah, you can. So I'm thinking here, 3 times 2 is 6x, right? 3 times 2x is 6x. That's okay, right? And that's a minus sign in front of it. So I'll put it. What do you notice, though, about the factor x squared minus 4? top you got 2 of them squared. Here you got to the power of 6. So you have more on the bottom than the top. These 2 will cancel. You're going to be left with 4 there, right? It's a messy 4 there, but okay. So I'm going to put that on the denominator. By the way, denominator is denominator. Denominator, mispronounced on purpose. That's not too shabby, is it? Okay. There's another way you could have thought of it. Some people prefer it this way. You could have, and I'll just say it this way. You could have rewritten this as x squared minus 4 to the negative 3. And that's the same expression, isn't it? And then apply your negative 3 as the outside function. You get negative 4. And then, but you'd still have to, it's basically, it doesn't save you that much work. But you get the exact same answer doing it that way as well. Okay? You could toy around with that if you wish. Questions? I got it broken up into 2 or 3 parts. So. Using a table of values to do things like this thing. And then we're going to, then we're going to get you to do some of those. Here's a table of values for f, g, f prime, and g prime. Shown. So if you understand these rules, and you'll get more practice, you'll understand them better. Try these out. Everybody sees how the chart works. Your x values, your function values, your g function values, your derivatives. Oh, didn't mean to do that, but whatever. Okay. What was that all about there? So A, if what we're going to call capital F for this function, I didn't mean to do that either. I'll lock this in. F, would you guys know that notation? F-O-G, like F of G of X? That means F, G is on the inside, okay? I prefer saying F of G of X, though, with brackets, okay? Then find F prime of 4. Well, let's look at this. So I'm going to do A. F, I'm just rewriting this into what I find easier notation for me to fathom. F of G of X. That's all. I haven't done anything at all. It's just, that's the equivalent of what's written here, right? That's all. If that's the expression, what is the derivatives expression? Well, that's going to be derivative of the outside, leaving the inside alone, times the derivative of the inside expression. Right? That's just the chain rule rewritten. I haven't really done anything other than rewrite the rule with colors. Colors are nice. Figure, whatever, I'll leave that there. We wanted to evaluate f prime of 4. Okay, f prime of 4. So I'm just going to plug in 4 anywhere I see it here. So f prime of 4 is equal to small f derivative with g of 4 inside times g prime of 4. Now we're going to use the chart and substitute some values. And it'll all be hunky-dory.
Nice story.
So, we got to look some stuff up on this chart. First thing is what's g of 4, because that's what we're supposed to look up. G at 4 That's 3. So I'm only doing one thing inside here at a time. So this is equal to, still outside, I still have to do f prime of something. When I looked up g of 4, as I said before, it is the number 3, right? That's what it is. So that's where I'm getting that from. And then the g prime of 4, 2. Thank you. 2. Okay. We still have something to look up then. We've got to look up f prime of 3. Because you use whatever's on the inside in your next practice. F prime of 3 is 8. I think it's great. 8 times 2, 16. Now, I think you could have done 8 times 2 in your head and just wrote 16 down, but I'm trying to instruct you. When you try something like B, you should get 28. If you try your turn 3, you should get, it'll work out, 80. So something like B, I'll just put the answer here and see if you can do it. Here, this should be 80. If you use that same chart of values, okay? Now, I have some circle questions to try. And yeah, take it away. The answers are given as well. I'm going to stop the recording. And we can do